welcome to this episode, which is episode 5 of our sessions where we are looking at the 2021 grade 12 GCE Mathematics paper 2. So the first 4 episodes has focused on question 1 through question 4. So let us look at question 5 today. So question 5 leads, find the equation of a tangent to the curve y is equal to, so we have basically y is equal to 5x to the power 3, then minus 7x squared, then plus 3x plus 2 at the point 1, 3. So if an equation is tangent, so at the point of tangents, this is a curve, at the point of tangents, this equation and the curve, they share the same gradient. They have the same gradient. So that's a key principle that you need to know. They share the same tangent. Then a general equation is given by y is equal to m, which is the gradient, multiplied by x plus c. So we need to find the gradient. So at this m, we can find the gradient m when we know the gradient of the curve. So to find the gradient of the curve, we differentiate with respect to y. So we are saying, what's the change in y as a result of change in x? When x changes by 1 unit, by how much does y change? That's what the gradient means, or the first derivative. So we do dy dx. So now when you're differentiating, what it means is, differentiating, we subtract a power. So we're subtracting a power to the original power, okay? So what it tells us, we have basically 3 times 5, we get basically a 15, then x reduced by the power 1, so x to the power 2, then minus, then this x to the power 2 multiplied by 7, we get a 14, okay, 2 multiplied by negative 7, we get a negative 14, then x reduced by the power 1, so it's x. Then we come to here, 3 to the power 3x, it means x has the power 1, so it's a 1 times 3, we get a positive 3. 1 times positive 3 is a positive 3, then x to the power 1 minus 1, so it's x to the power 0. Anything less to the power 0 is a 1. 1 times 3 is a 3. Then we have this constant. When x changes, the 2 will not change because it's a constant, so it does not change. So the change there is a 0. That's why this one just drops out. So then we remain with this. So now we need to find the change, the value at this. What's the value when x is equal to 1? So in this one we substitute, so we are getting basically 15 multiplied by 1 to the power 2, which is x here. X is 1 there. Then minus 14 multiplied by 1 plus 3. So 15. So here basically what we end up with is basically 1 times 1 is 1 times 15 is a 15 minus 1 times 14 is 1 times negative 14 is negative 14, then plus 3. So this is just a 1 plus 3, we get just a 4. So our gradient there is basically a 4. Hence this equation, the general equation, can be written now as y is equal to, because we know what m is a 4. Okay, a tangent, they share the same. Then what we need to do is, for this equation to be complete, we need to find the value of c. So we need to find the value of c. So if you know the connection, which is the gradient, the slopeness, for every 1 unit change in x, y will change by 4, we can find the value of c because we know the coordinate. So at this coordinate, we know the value of y. The value of y is 3, so we'll put a 3 there. Then 4, what's the value of x? Is a 1 at that point, then plus c. So 3 is equal to 4 times 1 is a 4 plus c. Then 3, we collect the like terms, so 4 comes this side. The moment it crosses the equal sign, it becomes a negative. So 3 minus 4 is equal to c. So 3 minus 4 is negative 1. So c basically is equal to negative 1. Hence, this equation now can be complete. So we write it now in the final version as y is equal to 4x minus 1 as the answer here. So for us to get these 3 marks. So basically, that's how you answer part A. Let us go to part B. So part B, basically, let me just try to clear the board so that we have part B. So part B leads in the diagram below. OA, okay, OA is equal to A, vector OB is equal to B, then X is the midpoint of AB, expressed in terms of A and OB, BA. So BA, so I'm moving from basically B to A. So if you go B to A, we are saying B to A is in this direction. Okay, B to A is in this direction, which is the opposite of AB. Okay, the negative of AB. So what we need to do is, how can we go to BA? So to go to BA, we need to go back to O from B, then get to A. So basically it's basically BO, which is the inverse of the negative direction of OB, plus OA. So what is BO? So BO is the opposite of OB. Okay, so it's in the opposite direction, so it's a negative. So if you are moving in the opposite direction, we introduce a negative. So OB is basically B. So the opposite direction of OB, which is BO, is basically negative B. This small b, you see, this one. Then plus, what is OA? So OA is this A, so we get this vector A. You see, this vector A. You see? So basically, we end up with A, this vector, then minus, so we have A minus B, this vector. So this is our, basically, the answer to A. Okay, B Roman numeral A. Then let us look at AX. So AX. So AX, we are told X is the midpoint of AB. Okay, AB. So AB, we are going in this direction. Then AB, so if you look at AB, is basically the same as the negative of what? BA. Okay, so we just reverse the direction of BA, then we will get AB. But what we know is, if X is in the middle of AB, so meaning AX, just going up to X from A, is half of AB. Then what AB is the inverse of that. So we've already found the BA, so it's just half. So this half, then we get multiplied by, so half of, so we are multiplying by, then reverse the direction of BA, which is in this case A. This is basically the AB that we found. Remember that we found it just here. Then from there we can proceed. Multiply by, so we have half, basically we reverse now is this B vector, then minus this A. We reverse because of the negative. This is negative, then that one becomes a positive. So this is basically B. So let us look at C. C OX. So OX. Okay. So OX, basically, if you look at OX, so it's this direction. So OX, from O to X, we can also move by moving from OA, then we add AX. So OX is given by this direction by moving from O to A, then plus AX. So it's important that you get AX correct. Otherwise, if you mess up AX, then you mess up everything. So OA is given to us, no problem. This one. Then AX, we find this one to be half multiplied by B minus vector A, like this. So if you simplify this one to be A minus this, because it's a negative, so we end up with just half B minus half A, this vector A, then plus this A, which is this side. So we'll end up with basically half B plus A vector. Okay, so it will just be half BA vector. So basically, this is how you answer part B Roman numeral 1. Let us move to part 2, Roman numeral 2. Say, given that OC, so given that OC, so O to C is equal to 3A. Okay? Express BC in terms of A and B. Okay, that one is quite straightforward, and it's basically 1 mark. Why? Because it's even much more straight than the other one. So we are looking for a BC. So we are looking for from here to here BC in this direction. Okay, so the from B to C, the one we can get from B to C, the other direction is moving from B to O, which is the opposite of OB, then now proceeding from O to C. So we know that OC is 3A, so you multiply this by, so this is basically twice. So OB is straightforward, so OB is B, but BO is a negative, so it becomes negative B, it's opposite of BO, then plus, we know what OC is, from O to C is 3A. So this is nothing but 3A vector A minus this B. So this is basically how you get 5B Roman numeral 2 to get that 1 mark, so that you get that 8 marks in total.